Example 3. That looks like an A. Find, that's still not good. That's still not good. I'm going to erase it. Let's see how that works. Find, find. This is difficult. Find the volume resulting from revolving the enclosed region about the y-axis. Ooh, about the y-axis, huh? Find the volume resulting from the revolving around the region about the y-axis. Ooh, the y-axis. The y-axis. That's a little bit different. So first, you draw a picture. Let's draw a picture. A lot of the time you want to solve for y anyway, just so you'll be able to graph it a little bit easier. But let's draw the picture. We have, undo that. We have what's x squared minus 1. That's just, we go down 1, right? It's just like, x equals 0. That's the y-axis. And y equals 3. Oh, what? What is this? Y equals 1, 2, 3. So that's y equals 3. I will write that. Y equals 3. Y equals x squared minus 1. And we're trying to find that revolved around the y-axis, huh? That's different. So this time, our radius is sideways. This is insane. So it looks like that. That's how we get it. Oh, and we have to integrate from here up to here. Yeah, do you guys see that? So this is a little bit different. Oh, if I'm integrating with respect to y, I should solve for y. That's important. And I'm going from -1 all the way up to 3, and that's for the y. So that's not so bad. Let's see. My y equals x squared. Was that -1? I'm going to solve for y. So plus 1, I said. So I get x squared equals, y plus 1. If I square root it, I get x equals plus or minus the square root of y plus 1. However, I'm only dealing with the right side, so I'm going to deal with the positive x, which means I only have to write the positive part of that. So I don't have to write plus or minus, because I'm only dealing with that side. All right. This shape would look like an acorn again. Looks like that. Oh, that's beautiful. There's an upside down bell, huh? Outside it's like a bowl, like a little bowl. Ebola. This is like acorn, like that. All right. Yeah. So that's very good. Very good. My radius is sideways, and that's just this distance from here to here, and that distance is just what I wrote down. That's what that distance is. That's very good. That's very good. Let's see. So I'm going to start integrating. That was solving. I'm going to figure out my integral. My integral should be, was a pi out there, and I'm integrating from -1 to 3, right there. And so -1 to 3. And my inside function for my radius, that'll be the square root of y plus 1. I have to solve it in terms of y, and I have to square it as well, because I'm revolving around the y-axis, so that's important. So when revolving about the y-axis, get in terms of y. That's what I did. It makes it super easy. This is easy. Easy peasy, lemon squeezies. It's from -1 to 3. It'll be y plus 1 dy. That'll give me y squared plus y. Evaluated from -1 to 3. There's the pi there, and 3 squared is 9. Plus 3 minus 1 plus -1. That goes away. That's beautiful. This is beautiful. And then a pi outside. So 9, 10, 11, 12. 12 pi. Sweet. Wait a minute. Why was I doing it from -1? Because my function went to -1. But it said x equals 0 to y equals 3. Oh, no, that's fine. You silly goose. This is supposed to be, I found it. I found where I messed up. This is supposed to be over 2, right? Yeah, you silly person, you. Who is you talking to? You're talking to myself. You are talking to you. You silly. So, yeah, it should be that, huh? Okay. Let's see what happens here. Is that right? I don't even know. Yes. Okay. So I put in the 3. There's 9 over 2 plus 3, which is the same thing as 6 over 2. Right? It's the same thing as 6 over 2. So I just get a common denominator. Minus the hand of minus, 1/2 minus 1. And that's all times pi. Alright. So we get 9, so it's 15 over 2. This becomes negative 1/2. And then times a negative, that becomes positive 1/2 times pi. So that's 16 over 2, which is 8 pi. And there we have it, folks. That's all she wrote. This is the shortest video. Good day. I said good day.